Hello again, everybody. Right now we're going to discuss section 1.3, which is going to begin talking about angles. The first thing we need to talk about is an angle in particular. An angle is simply going to be formed by either two rays as the sides where there's a common endpoint, and this endpoint here is called the vertex. So a vertex is always going to refer to something where a point is at an angle here, like almost like a corner. If you're looking at shapes, you can look at like the corners as vertices. That's the plural of a vertex. Also, when you name an angle, naming angles, okay. Typically what you'll need either is so let's say we've got this here. Let's say this is A, this is point B, and this is point C. Remember, B here is the vertex. We can name this as either angle, and angle is going to look like this mini angle. It's almost like a crooked L. Angle B, or you can say angle ABC, or you can say angle CBA. The ordering does matter in geometry, so we can't just flip these around anywhere. You'll see in either of these, B has to be in the middle. Okay? So the measure of an angle is typically given in degrees. If you guys go on to take trigonometry, then you'll see that there's different things, but in geometry, all we use is degrees. And degrees are going to be represented with this little, it's a little circle above the number. And you guys have seen this when you're looking at either like Fahrenheit or Celsius. It's the same symbol. There are different types of angles. An acute angle. This one is going to look something like this. This is less than 90 degrees. Okay. Greater than 0 degrees, but less than 90. A right angle. A right angle is going to be exactly 90 degrees. And typically a right angle is going to be marked with this little square box in the angle. And then we've got an obtuse angle. This is going to be greater than 90, but less than 180. And then the one you guys might not have been familiar with before is called a straight angle. A straight angle is basically a line formed with two opposite rays. This is exactly 180 degrees. That's the measure of a straight angle. All right. The next thing we'll talk about, just like we had before with segments, we can have congruent angles. So congruent angles, these will be marked. So if this one and this one here are congruent, we will mark them with this little arc in the angle. Okay. Also similar to segments, we have the angle addition postulate. Angle addition, basically if you've got a big angle here made up of two smaller angles, so let's say this is point A, let's say this is point B, let's say this is point C, and this over here is point D. We can say that angle ABD plus angle DBC equals angle ABC. So if you go from this angle here, and then you add onto it this angle here, it's the same thing as having the whole angle all together. All right, so let's do an example really quick here. So let's say that the measure of angle ABD is 37 degrees, and this little m in front means measure, and the measure of angle ABC is 84 degrees. Find the measure of angle DBC. So here again, we'll draw a picture. Here's A, here's B, here's D, here's C. So ABD is this one here. So this thing is 37 degrees. ABC, which is this whole thing, is 84 degrees. So if the whole thing is 84 degrees, we're trying to find just this little part in here. So to find the little part in there, what we can do is subtract 84 degrees minus 37 degrees, which will give us 47 degrees, and that's going to be the measure of angle DBC, or the measure of just this little part down in here. Okay. The next thing, again, similar to segment, we can have an angle bisector. Basically, this cuts an angle in half. Or in other words, it makes two congruent angles out of one, it makes two congruent smaller angles out of one big angle. So let's do another example here. Example 2. Let's say that ray BD bisects angle ABC. Let's say that the measure of angle ABD is equal to 6x plus 3 degrees. Let's say the measure of angle DBC is equal to 8x minus 7 degrees. And then we want to find the measure of angle ABD. Okay, so here we'll have a picture. This vertex here is going to be B, this is going to be A, this over here will be C, and this here will be D. So it says BD bisects ABC. So ABD is 6x plus 3, and DBC is 8x minus 7. Well, since it's bisected, it means that these two angles are going to end up being congruent. So 6x plus 3, remember congruent means equal. 6x plus 3 is equal to 8x minus 7. We can solve this as an algebra equation. 3 equals 2x minus 7. You can add 7 to both sides. 10 equals 2x. Divide by the 2, and you get x is equal to 5. Now, this is not what we were looking for. We wanted to find the measure of angle ABD. So in order to do that, we have to take this 5 and plug it back in for x. So the measure of angle ABD is equal to 6 times 5 plus 3, which is 30 plus 3, or 33 degrees. And remember, whenever we're talking about an angle measure, we're always going to be looking at it in terms of degrees. All right, guys, I will be back with the next video with section 4.